This technical analysis examines the mechanical failures in a vehicle tipping incident, focusing on the physics of load distribution and axle weight limits. The truck effectively acts as a lever where the rear axle serves as a fulcrum. When excessive weight is positioned too far back, the resulting rotational torque exceeds the front-end weight, causing the cab to lift. Maintaining the center of gravity between the axles is critical, as a shift outside the wheelbase results in a total loss of steering and front braking power. Furthermore, concentrating tons of cargo on the rear axle risks immediate mechanical failure, such as snapped axles or tire blowouts. Operational factors like high launch inertia or uneven terrain further escalate these risks. To prevent such hazards, loads must remain centered and compliant with gross axle weight ratings to ensure structural integrity and traction. This high-speed work zone near miss highlights the immense kinetic energy of commercial vehicles on interstates, where a mechanical failure can make a vehicle's trajectory unpredictable. As seen in the footage, an errant truck breached temporary barriers and struck a maintenance unit with incredible force. Despite having a shadow vehicle acting as a shield, the out-of-control truck found a gap, proving that physical barriers have vulnerabilities. For personnel, auditory blind spots and visual limitations are major risks, yet the worker's 1-second reaction time saved him. This incident underscores the need for truck-mounted attenuators and adequate buffer spaces to prevent a domino effect. To stay safe, workers must always face traffic, identify a clear escape route before starting tasks, and utilize intrusion alarms to provide early warning of approaching hazards. This technical safety analysis examines the mechanical and behavioral failures in an industrial coil handling incident. Steel coils, due to their cylindrical geometry, are highly susceptible to rotational motion. When unsecured, a shift in internal tension or a trailer's slight incline creates massive kinetic energy that human strength cannot counteract. A common but dangerous error is the property protection reflex, where workers instinctively attempt to save cargo instead of prioritizing self-preservation through a flight-over-fight response. Systemic failures often include unstrapping loads before stabilization equipment like forklifts or cranes are engaged, creating lethal pinch points. To prevent these crush hazards, facilities must mandate the use of mechanical chocks throughout the process and enforce the rule of distance, requiring personnel to remain outside the red zone until the material is fully secured. Safe egress skills and strict adherence to SOPs are the only effective barriers against such immense momentum. The technical failure in this material handling incident stems from a critical miscalculation of the center of gravity and leverage. Industrial units like commercial refrigerators are inherently top-heavy. As the worker tilted the equipment to load it onto the truck, the center of gravity shifted outside the base of support, creating uncontrollable torque. A significant safety breach occurred through solar operation and a lack of engineering controls, such as hydraulic lifts or non-slip ramps. The worker became trapped in a confined space due to an instinctive attempt to stabilize the falling mass instead of clearing the area. To prevent such accidents, organizations must prioritize pre-job risk assessments, rigorous lifting training, and a safety culture that mandates mechanical assistance for bulky loads. Ensuring equipment integrity and utilizing proper aids are essential to protecting personnel. This analysis highlights critical failures in stacking stability and warehouse safety protocols. The incident resulted from a domino effect caused by non-interlocking columns. Removing rod bearing back at the bottom created a structural void, leading to a total collapse. Engineering-wise, the head-to-base ratio was exceeded, making the narrow stacks highly unstable. Operational errors were evident as workers bypassed the top-down retrieval rule, turning overhead inventory into high-mass falling hazards. Furthermore, the lack of racking systems and excessively narrow aisles eliminated any viable escape routes. To prevent such risks, facilities must implement interlocking stacking patterns, invest in pallet racking to isolate loads, and enforce strict safety training regarding danger zones. Adhering to standard operating procedures is essential to maintaining a secure workplace. This high-rise falling object incident highlights critical rigging and structural failures where improper load securing allowed a crate of bricks to shift, leading to strap failure and a catastrophic free fall. Objects falling from the 8th floor accumulate massive kinetic energy, rendering standard PP like hard hats ineffective against such bulk impacts. Key personnel errors included line-of-fire violations and a breakdown in communication between the crane operator and ground crew. To prevent such events, the exclusion zone principle must be strictly enforced with physical barriers and spotters. Operational standards mandate using certified lifting cages for loose materials and conducting thorough pre-lift inspections. Implementing perimeter safety netting and a strict never under the load policy, supported by dedicated safety oversight, remains the final line of defense. This technical analysis examines the failures in energy control and situational awareness during vehicle maintenance, highlighting the critical importance of standardized safety protocols. The primary technical failure was the absence of wheel chocks, allowing for unintended movement driven by residual brake pressure or gravity. When components like cabins are tilted, even minor shifts in the center of gravity can cause mechanical parts to close the gap between the frame and chassis. Furthermore, the worker violated pinch point protocols by standing in a high-risk zone without a clear path of egress or work zone isolation. Adhering to lockout principles and utilizing physical safety struts are essential to negate potential energy risks. Ultimately, maintaining a buddy system and conducting thorough 360-degree inspections ensure that personnel remain clear of blind spots and hazardous zones during heavy vehicle maintenance. This industrial lathe entanglement incident demonstrates the dangerous physics of torque and rotational force, where extreme mechanical power and inertia create pulling forces far exceeding human strength. Operating at high RPMs, a rotating shaft leaves an operator zero time to react once entangled. Technical failures often include inadequate machine guarding in running nip points and the use of inappropriate PP, like loose clothing, which acts as a tightening rope in U.S. safety culture. Essential engineering controls include highly accessible emergency stops, safety interlocks, and electromagnetic braking to eliminate coasting inertia. Preventing such incidents requires a strong safety culture that utilizes the buddy system for mutual accountability and addresses complacency risks to ensure operators never reach into red zones while the spindle is active. This technical analysis evaluates the mechanical and operational failures in industrial lifting and material handling, emphasizing the importance of adherence to safety protocols. A primary engineering failure involves inadequate rigging and containment. When lifting loose materials from heights, primary strapping is insufficient without secondary containment like lifting cages, as shifting centers of gravity can cause catastrophic load releases. Furthermore, objects falling from significant heights accumulate massive kinetic energy, rendering standard PP ineffective against direct strikes. Human factors also play a critical role, particularly exclusion zone violations where personnel enter the line of fire. Workers must overcome the misguided property protection reflex as the momentum of heavy cargo far exceeds human capacity. Additionally, maintaining the hydraulic integrity of support equipment and prioritizing pushing over pulling helps prevent dangerous pinch point incidents. Ultimately, enforcing lockout procedures and the person over property principle, alongside 360-degree per-shift inspections, serves as the final defense against high-risk industrial accidents. This technical safety analysis of the lifting and rigging incident highlights a fundamental miscalculation of the metal cylinder's center of gravity. When lifting points are asymmetrical, the load instinctively rotates to find equilibrium, transitioning from a static to a dynamic load. This shift multiplies the force on rigging hardware, risking mechanical failure. A critical lack of directional control, specifically the absence of taglines, prevented workers from stabilizing the load from a safe distance. Furthermore, exceeding safe sling angles increased tension exponentially, contributing to the instability. The presence of personnel within the fall cone or exclusion zone created a point of no return when the load began to swing. To prevent such incidents, OSHA standards require a trial lift to verify balance, per-shift rigging inspections, and the use of a single qualified signal person